Have we seen the answer and where it comes from?
Yes.
So number 2, Roman 2 is saying what of that number?
6.02 times 10 exponent 23.
10 exponent 23 of what?
Of lead.
Of lead. So this is Melissa. Get for me that answer. Neha, get for me the answer of Roman 3. Neha? Neha? Neha?
Yes, teacher.
Read for me Roman 3 and get for me the answer. Particles, how many are they? Hmm? It is what?
It's
Neha, you read for me that one.
0.6
0.6
times 10 power 12 particles
particles
of manganese.
of magnesium, not manganese. Okay, you get for me this answer. I want the one of Neha. Then this one is for Melissa. Melissa, have you finished?
Once less.
Okay. I'm not seeing senior threes here. Where are they? So let's look through this question. Let's look through this question to add more question on this. Which question is related to what we're discussing? Let's look at question number 10. Let's go through question number 10. Let's go through question number 10. Remember? They have said a water pump must work at a constant rate. Okay, so time is going and we have to chase time. We have very many things to do. Lead. What is the answer, Melissa? Start with our very own statement that says 1 mole, or if they have given us particles, you say 6.02 times 10 to the power 23 particles of lead. 6.02 times 10 to the power 23 particles are contained in 1 mole of lead. 1 mole of lead. So then you ask yourself a question. If these are 6.02, what is 1 mole of lead? 1 mole of lead is equivalent to what in terms of relative atomic mass? Somebody read for us. It is 2.7, isn't it? Grams. So if these are 2.7 grams, so the question is asking us the same number of this. So this number of what contains the same grams? So it is 207 grams. That is all. This is 6.02 particles. You say 6.02 times 10 to the power 23 particles of magnesium particles are contained in 1 mole of magnesium. In 1 mole of magnesium. Then you ask yourself a question. 1 mole of magnesium is equal to 24 grams, isn't it? So these 24 are the ones that these particles have. What about 0.6 times 10 to the power 12? What is the answer? Yes?
2.392.
2.392 grams.
Okay. So those are the answers I expected people to get. Those are the answers I expected people to get. I don't know where senior threes are. Do you have any senior three here? Huh? Do you have senior threes here?
No.
Okay. That is good for them. So all questions come in that way, and whoever did not do the work, then I'm sorry for you. Now, when such numbers come, please just use the comparison that 1 mole. In our summary, that's what you do in mole concept. 1 mole is equal to 6.02. If the question comes in terms of particles and moles, please, this is the conversion you need to get. 23 particles. That's the first statement for you to write. 2, 1 mole also is equivalent to relative atomic mass of any given substance, and this you obtain it from the table. From the table. If it is not given, you check the table. Also, since now this is equal to this, then therefore 6.02 times 10 power 23 particles are equal to the relative atomic mass of any given substance, or any substance or any element. That is the first statement we write on the ground. Okay. When they ask for ions, you must also know that the number of ions is also equal to the same number of particles equal to anything they ask. So you must know how things ionize. If they ask for aluminum sulfate, you must know that aluminum sulfate is written like this, SO3. Now when it ionizes to give us individual ions, it becomes aluminum. Since there are 2, it becomes 2. The charge of aluminum is 3 plus aqueous plus sulfate ions, SO4. There are 3. Then the charge of this is 2 minus aqueous also. Now, when they ask for anything here, find the number of aluminum ions in aluminum sulfate, in 1 mole of aluminum sulfate. In 1 mole of aluminum sulfate. Just know the relationship between aluminum sulfate and this. The rest, you will find them there. So all those examples have been there. For those who have the book, you can check this in particular here, and it will give you the way forward of going, of doing that number. Then we want to go and discuss today this main part here. Converting moles, you relate this with the relative atomic mass for any substance. That one you have done. And these are the exercises. 2.16 grams of silver, that one we can do now. Now, when they ask for a compound like this, they say 22 grams, calculate the number of moles in 22.2 grams of calcium chloride. Calcium chloride. Then what you should do is you must first know the relative atomic mass. For you to do this, you must write that 1 mole of calcium chloride equals to relative atomic mass of that substance. Relative atomic mass of calcium chloride, calcium is like this, Cl, it has a valence of 2, chloride is C minus 1, so calcium chloride is written as this. Now, calcium is 40 plus fluorine, which is 35.5 plus times 2. These are 2. It is 40 times 35.5 times 2. This is a plus. So this is 71 already plus 40. The answer is 40 plus 71. You get 111, isn't it? Grams. Yes? Hey, am I here alone?
You know, yes.
Very good. I thought I was alone. Then you say 1 mole of calcium chloride, 1 mole of calcium chloride is equal to or weighs 1 grams. What about now? They have given you grams from the question. So you write the statement starting with the grams. So you say 1 gram of calcium chloride are contained in 1 mole, are contained in 1 mole. What about 1 gram of calcium chloride? It is contained in 1 out of 111 moles. What about 22.2 grams? So this one will be 1 out of 11 times 22.2 moles. So what is the answer there?
We said volume power, volume per second is equal to area times velocity.
What is the answer?
Area
2 moles, isn't it? So that is the way. If they bring a compound, make sure you look for the relative atomic mass of that compound. So 1 mole is equivalent to relative atomic mass of any substance or compound or an element. That is the final. So all these questions, 88 grams of carbon dioxide. Can somebody get for me the number of moles in 88 grams of carbon dioxide? 88 grams of carbon dioxide. Start with 1 mole of carbon dioxide is equal to the relative atomic mass of that. Then rewrite the statement starting with the grams you have got for easier access to the question. You have 1 minute. So when the clock's 10:46, I should see the answer.
What do you have? 3 points. Please calculate for me. You are getting the area. What is 3 points? For me, I've got 3.9. 9, 0, 7 times 10 to the power -4 meter squared. Meter what? Meter squared.
How many moles are there in 88 grams of carbon dioxide?
So as simple as that. As simple as that.
What is the answer?
So the rest that is your work now.
Let's learn to be quick. The more you make the head reason very fast, the more you work things out in chemistry.
The first one is saying define work and energy. You will waste time there. Write your answer down, please. Write your answer down. Repeat on now. Now we are repeating on that. Finally, by saying explain whether a person carrying a basket of water does work on a basket while walking on a level road. Explain whether a person carrying a basket of water does work, does any work on a basket while walking on a level road.
What is the answer?
Is that going to be one level?
Hey, don't keep quiet. What is the answer?
Why?
7.3 grams.
7.3 grams. 7.3 grams. Somebody can prove, is that answer correct?
Yeah, it's 7.3 moles.
Moles. Okay. How many people are here? Let me check. Somebody else give us the answer. So is that Lynette? Lynette,
What's the job?
are you the one?
Yes.
How did you start with your work?
1 mole of carbon dioxide
Weighs
so we use carbon.
this is carbon.
Okay. Weighs 12 moles.
1 mole
12
of
grams.
1 mole of carbon dioxide weighs.
12 grams.
Do you know what to write carbon dioxide?
Carbon dioxide.
Please don't ashame me at this stage. Carbon dioxide. Some people on the chat, my mouse has failed to work. You tell us the answer.
Yeah, it weighs 44 grams.
44 grams. What about 88?
88 grams equals to 1 out of 44 times 88.
Get for me the answer. What is the answer? 44 grams, correct?
Answer is 2 moles.
2 moles. Thank you very much. As easy as that. Okay? So all those come from there. So our answer should be in relation to that. So I expected people to give me I expected people to give me 2 moles, not 7.3, not as somebody has said 0.03. What we say is 1 mole of carbon dioxide weighs 44 grams. Now, since they have given us grams, you start with the grams. So you say 44 grams of carbon dioxide are contained in 1 mole. In 1 mole. What about 1 gram? It's the same as 1 of 44 moles. What about what? 88 grams. So this one is equivalent to 1 out of 44 and 88. So this is 1, this is 2. So the answer is 2 moles. Is it clear now? Yes. So if they say the number of moles in 6 grams of ammonia is NH3. So 1 mole of ammonia is equivalent to what? Is equal to, or it weighs, what does it weigh? Yes. 3 times 1 plus 14. What's the answer? Grandma. Grandma.
Pardon?
Ammonia is 3 times, which is 1 times 3, plus nitrogen, which is 14. What is the answer? It weighs?
It weighs 17.
17 grams. So start with this, since they have given you grams. So you start with this 17 grams of ammonia are contained in 1 mole What about 1 gram of ammonia? It contains 1 out of 17 moles. What about 6 grams of ammonia? It is 1 out of 17 times 6 moles. So what is the answer there? Use the
0.3,
0.3,
5,
5 moles.
3.
So
Yes, moles.
you always make sure that your answer is to 3 decimal places. 3 decimal places, okay?
Yes, teacher.
Yeah. So that is a simple way of doing that number. You are converting moles to masses or the other way around. Now look at this 0.2. They have given you moles. You need to convert them to masses. Potassium carbonate. You must look for the relative formula mass of potassium carbonate. Then you say 1 mole of potassium carbonate. Where is that? What about 0.1? Then you look for the grams. So all that is the work for you to try out at your own free time. Now, there is empirical formula left, but I want us to finish percentage composition. Percentage composition of an element in a compound. In a compound. You might be given a compound like ammonium sulfate. Ammonium sulfate. Now, if you write a wrong formula of a given substance, you will never see the correct answer. If they ask for percentage composition, percentage is the what? They ask for percentage. That means you are going to get, maybe they want the percentage of hydrogen in ammonium sulfate. So you are going to get the stand of hydrogen in this compound. So if you are looking for the percentage composition of a given substance in a compound, is like the overall mark is 100 and you manage to score 10. Those are your marks, 10. And they want the percentage is going to be 10 out of the overall mark, which is 100 times 100. If a paper is marked out of 20 and you get 1 out of 20, it's going to be 1 out of 20 times 100%. That is the percentage composition of the percentage composition to what you have got. Now, in this topic also, you will be told to calculate the percentage composition of any element from a given compound. So failure to come up with the correct compound, you will earn enough zeros as you can. Just like the other way, if you fail to convert particles to masses or masses to moles, you go on. If you don't know the relationship it has, you will always get low marks. So at this level, what they say percentage composition is, from the formula of the compound, we can calculate the percentage of each percentage by mass of each compound of each element in a compound. So percentage composition of an element is given by mass of an element over the formula mass times 100. Mass of an element times over the formula mass times 100. Formula mass is also the same as the relative formula mass. Relative molecular mass is the same as formula mass. All these mean the same. So if you know how to come up with a given substance, now let's look at this example. Calculate the percentage composition by mass of oxygen in calcium carbonate. Do you know how to write calcium carbonate? We are looking for the compound called calcium carbonate. How do you write calcium carbonate? Our next senior series to be should tell us calcium carbonate is Ca. Yes. Oh. Neha. Neha.
Yes, teacher.
Calcium carbonate. How do you write calcium carbonate? It is Ca. From the start of this, we need to write compounds. So this is where you need to know. You show your chemistry of compounds from. If not, it will always find problems. So calcium is 2 plus, carbonate is CO3, it has also 2 minus. So when they react, this and this cancels and we remain with calcium carbonate. So they want the percentage of oxygen in the calcium carbonate. Now let's look for the relative molecular mass of calcium carbonate. Calcium plus carbon plus O times 16. O is 16, okay, sorry, times 3. O is 16 times 3 plus carbon is 12 plus calcium, which is 40. What is that? What is the answer there? Do you have 100?
Yes, it's 100.
Very good. So then, if this is the relative atomic mass, we said percentage composition of oxygen is going to be a mass of oxygen, it's going to be a mass of oxygen divided by the relative formula mass of the given compound times 100%. Now, oxygen in this element, there are 3 oxygens, isn't it? So it's going to be O times 3 divided by 100, which is the relative atomic mass times 100. So the mass of oxygen is going to be 16 times 3 out of 100 times 100. This one and this will go. Then 16 times 3 is 16 times 3, you get 48%. Okay?
Excuse me, teacher.
Yes.
Yeah. Every time the answer, the relative atomic mass should be every time 100.
No, it differs. The relative atomic mass of calcium carbonate is not the relative atomic mass of calcium chloride. Is it the same? Yes. We found the chloride, which is calcium chloride, is the same as 111 grams, isn't it?
Yes.
Yes. So this is not the same. So what is the percentage of calcium in calcium carbonate? Percentage of calcium in calcium. This is for oxygen. What about the percentage of calcium? So when you add up all the individual components in a given compound like this, the mass total to the relative atomic mass of that compound, which is this. So if oxygen is 48%, calcium, what is the percentage of calcium?
It's 40%.
40%, very good. What about the percentage of carbon? 12%. So if I add 40 plus 48 plus 12, do I get 100?
Yes.
Very good. So I have got all my individual components and their percentage in that element. So all those elements, that is how they behave. That's how they behave. So here, you see this. What is the percentage by mass of water in copper 2 sulfate? Water, copper 2 sulfate, and then 5 water. They want the percentage of this. Now, last time I gave people relative atomic mass of iron 2 sulfate. Iron 2 sulfate, was it 7 water? Now, people found problems in calculating the relative atomic mass of this element. If you're calculating this, is going to be Fe plus S plus O times 4, because they are 4, plus 7, open brackets, water is already H times 2 plus 16, like that. Okay? Is that clear?
Yes.
So Fe is 56 plus 32 plus 16 times 4 plus 7 into, this is 2, 1 times 2 plus 16. So it's going to be 7 into 18 plus, this is 48 plus 32 and 56 is what? 32 plus 56, you get 88. So if you add up all this, you must be positioned to get for us the relative atomic mass of iron 2 sulfates. So that is all. That's one example. Two, let's go back to our copper sulfate. It's going to be copper plus S, which is plus O times 4, then plus 5 into water. Water is hydrogen times 2, there are 2 plus 16. Always, if the compound is big, use these brackets for easy identification. Because they want the percentage of water. Water is 5 H2O. It is not only H2O. There are 5 molecules of water in this element. So here you find 5 times what? 18 plus, this is 16 times 4 plus 32 plus 64. The final answer here is 48 plus 32 plus 64 plus 5 times 18, you get 90. These ones alone give us 64 plus 32 plus 48, gives us 145.